Chapter 1, Sampling and Data. In this chapter, we will cover definition of statistic, probability, and key term. Then we will cover data sampling and variation in data and sampling, experiment design and ethic, data collection experiment, and sampling experiment. So here's some key terms. In statistics, organizing and summarizing data is called descriptive statistics. Inferential statistics use measurement from the sample of the subject in the experiment to compare to the treatment group and make generalization about the larger population of subjects. Probability is a mathematical tool used to study randomness. Population is the pool of individuals from which a statistical sample is drawn for a study. A sample is a subset of the population. Statistic is a number that represents a property of the sample. A parameter is the number that is a property of the population. The sample must contain the characteristics of the population in order to be a representative sample. A variable, noted by the capital letter such as X, Y, Z, is the characteristics of interest for each person or thing in the population. Variable may be numerical or categorical. Data are the actual variable. Tandem is a single value. Mean is the average. Proportion is a part that's relative to a whole. For example, in part 1, determine what are the key terms referred to in the following study. We want to know the average amount of money spent on school uniform each year by family at the North Academy. We randomly surveyed 100 families with children in the school. 3 of the families spent 65, 75, and 95 respectively. So the population in this sample is the family at the academy. The sample, well, we do a survey of 100 families, so the sample contains 100 families. With children in the school, 3 of the families spend on this much. So the parameter is what is it that we surveyed? We want to know the amount of money spent on school uniform. Statistic is the amount of money spent on school uniform of 100 family. Well, the variable is let X equal to the amount of money spent on uniform. And the data that we get is 65, 75, and 95. In the next one, you want to determine the average number of hours of sleep college students get per day. Okay, so the population here is the college student. The parameter is the number of hours sleep. Well, the sample. Suppose yesterday in your English class you asked 10 students how many hours of sleep they get the night before. The sample here that you choose is 10 students in English class. The statistic is the number of hours of sleep of the 10 students. The variable x equal to the number of hours of sleep. And the data that you got are those numbers A, 10, 10, 7, 5, 6, 7, 8, 8, and 9. When we're collecting data, we have different types of data, variable and different types of data. So here we have some vocabulary, and I'll let you read it on your own. However, the two first things that I want you to pay attention to is the qualitative data are the result of categorizing or describing the attribute of population. Quantitative data are a result of counting or measuring attribute population. So one thing that you can count and the other one is more about categorize. Okay. So let's take a look at example. Determine the correct data type, quantitative or qualitative, indicated whether the quantitative data are continuous or discrete. So here we have the number of pair of shoes that you own. So you can count the number of pair of shoes. So this data is quantitative. Is it quantitative, continuous, or discrete? Well, it's discrete here because you can count it one by one, right? So this is discrete. The type of car that you drive. So there's categories. You can have a sedan, you can have a van, you can have different brand of the car. So this is the qualitative. The distance from your home to the nearest grocery store. Say from your house to the grocery store, 3 miles. Okay, so you can count this, so that is quantitative. And this is continuous. The distance is 5 miles. This is a continuous measurement. Same with the weight of the newborn baby. So this is quantitative, continuous. Let's talk about different types of sample. A study is done to determine the average tuition that San Jose State undergraduate student pay per semester. Each student in the following sample is asked how much tuition is paid for the fall semester. What is the type of sampling in each case? A sample of 100 graduates from San Jose State student is taken by organizing the student name by classification, freshman, sophomore, junior, senior, and then select 5 students from each. So here you divide students in groups, and then you take a proportionate number from each group. So this is the stratified sample. Okay. So you divide into group. Then take sample from each group. Next one, a random number generator is used to select a student from the alphabetical listing of all undergraduate students in the fall semester. Start with that student, then every 50 students is chosen into 75 students included in the sample size. So right here you have a system. You first list student in alphabetical listing, and you start with that student, right? And then every 50 student is chosen until you get to the number of students that you needed. So right here we have a system. So it's called a systematic sample. A completely random method is used to select 75 students. Each undergraduate student in the fall semester have the same probability of being chosen at any stage of the sampling process. So this is random. A freshman, a sophomore, junior, and senior years are numbered 1 to 3 and 4 respectively. A random number generator is used to pick 2 of those years. All students in those 2 years are in the same. So here you have a cluster sample. An administrative assistant is asked to stand in front of the library on Wednesday to ask the first 100 undergraduate students he encountered what they pay for tuition in the fall semester. Those 100 students are the sample of convenient sampling. Suppose ABC College has 10,000 part-time students. This is the population. We are interested in the average amount of money a part-time student spend on books in the fall term. Asking all 10,000 students is an almost impossible task. Suppose we take 2 different samples. First, we conveniently sampling and survey 10 students from a first-term organic chemistry class. Many of the students are taking first-term calculus in addition to the organic chemistry class. The amount of money they spend on books is as follows. Then a second sample is taken using a list of senior citizens who take PE class and taking every 5th senior citizen on the list for a total of 10 senior citizens. They spend the amount of money as follows. Do you think either of this sample is representative or in characteristics of the entire 10,000 part-time student population? Now, think about this. They're senior citizens taking PE class. They don't have a lot of cost for textbook, right? However, organic chemistry and math costs a lot more in the textbook. So either of this sample is the representative of the entire student population. So is it wise to use this result to describe the entire population? I don't think so, right? So data can be biased sometimes, depend on how you collecting those data.